Hey everyone, today we're looking at notes 2-3 attributes of absolute value functions today. So let's go ahead and begin. Graph each absolute value function and state the vertex and axis of symmetry. Okay, so if I'm looking to graph number 1, I'll give you a couple quick refreshers here. Remember that this is the A value, this is the C value, and this is the D value. Remember that the C and D value deal with left and right and up and down movement, and that's what changes the origin, while the A value deals with your vertical, stretch, shrink, or reflect, and that's what changes the ordered pairs or the points here. So first, like we've been doing, we're going to move the origin, so this +4 actually shifts the graph left 4, and then this -2 actually shifts the graph down 2. So left 4, down 2, so I'm going to pick it up and go left 1, 2, 3, 4, down 1, 2. There's my new origin. Okay, and then from there, remember this A value is what I multiply my Y values by to get my new ordered pairs. So I've went ahead and I've recorded the parent function points for the absolute value parent function, and now I'm just going to take my Y values, remember that's what I've been changing, my Y values, multiply them by 2. So this would become 4, this would become 2, 0, 2, 4, and then I cross out my original Y's, even though it's kind of hard since that color is so dark. I cross out my original Y's, that's gonna bother me. All right, and then I plot my new ordered pairs. So from my new origin, -2, 4, so left 2 up 1, 2, 3, 4. From my new origin, left 1 up 2, and then 0, 0, so on my new origin, and then 1, 2, and then 2, 4. Okay, and on today's graphs, what I'm going to have you do is I'm actually going to have you draw as many points as you can. So meaning I can't go any further here on this side, but I can keep going this way. So I'm going to keep going in this same fashion, up 2, right 1, up 2, right 1. And you're going to see why here in a minute. Since we're finding so many attributes, you're going to want to have as many points on the graph as you can. So then I'm going to, of course, I'm going to use my straight edge. Okay, got my straight edge and my arrows on both ends here. All right, and then we're going to state the vertex and axis of symmetry. So remember, the vertex is this tip point here that really cuts the graph in half. So the vertex is the ordered pair -1, 2, 3, 4, -2. And as you already, I'm sure, have noticed, that literally comes from the new origin. So we moved left 4 down 2, hence left 4 down 2, -4, -2. So you can see where those values come from. And then the axis of symmetry is this line that cuts the graph in half. So if I were to fold over this dashed line, my axis of symmetry here, then these points would be mirror images, right? You would fold them and they would lie on top of each other. Okay, so our axis of symmetry is the line x equals, because it's cutting through the x-axis at -4, and as I'm sure you already guessed, it's always going to be the x value of the vertex, because the vertex is the middle of your absolute value graph. Okay, so now let's get to analyzing the min and max on the given interval. Okay, so min and max on the given interval. So I've already written this note here. Remember that this boundary here is a domain. They're giving you the domain or the x's. So my interval is -6 to -3. So I'm going to go ahead and use my highlighter. So -1, 2, 3, 4, 5, 6. -6 to -1, 2, 3. So that's a pretty small interval there. And remember, I'm using a solid line, not a dashed line, because these are brackets. So the border or the boundary is included, okay? So we are looking at everything in between and on the boundary. And we're asking ourselves, what's the min or the lowest point within that region or on the boundary? And what's the highest point within that region or on the boundary? Okay, so looking either within the region or on the boundary, it's clear to see that our lowest point is this one here. So this is unlike your linear graphs where both the min and the max came from the boundary. Okay, here this vertex is the low point within these two boundaries here. So our min is actually going to be the ordered pair f of -4 equals -2. So exactly the vertex. The vertex is our min within this region and on the boundary. Our max is actually going to be this point here. I'm sure you can see that's the highest point, and that's f of, I believe it's -6. I'll come here and double check it here in a minute. 1, 2, well, yeah, it's on the boundary. Duh, I'm sorry. So f of -6, and that y value or that output is +2. So there's my min and there's my max. Now it wants us to give the domain and range and interval notation and the intercepts of the function. So the domain, how far left and how far right does this graph span? What x values does it use? Well, all of them. It goes all the way left, all the way right forever. So in interval notation, remember that's -infinity to +infinity. And then the range, remember, is talking about our y values, how low and how high. So the lowest y value this graph uses is -2. And of course, since it's a closed circle, we get the bracket, comma, it goes forever and ever and ever. So we go all the way up to +infinity. Okay, our x-intercepts, this is why I said you wanted to draw as many dots as you can, because you want to clearly be able to see where the x and y-intercepts are. So the x-intercepts are the ordered pairs -5, 0. Can you see it? I'm sorry, I'm getting off the screen here, aren't I? And -3, 0. Okay, those are your x-intercepts. That's where the graph cuts through the x-axis. Our y-intercept, singular, is 0, 1, 2, 3, 4, 5, 6. 0, 6. Okay, so not too bad when you do this stuff graphically, right? Okay, so on number 2, let's go ahead and graph first like we did before. So our origin shifts, remember that's left 2, up 3. So we're going to go left, 1, 2, up 1, 2, 3. There's our new origin. Okay, our a value tells us we need to multiply our y values by -1, so negative y in other words. So this would become -2, -1, 0, -1, -2. And I'm going to make sure and use purple too so our eyes aren't caught by that. I want to make sure we're seeing the right points here. So plot our new points, -2, -2 from our new origin. So left 2, down 2, and then left 1, down 1, and then 0, 0, and then 1, -1, and then 2, -2. And again, we're going to continue on this graph and just keep going in both directions until we can't anymore. And then we're going to use our straight edge. Draw our arrows on both ends. Alrighty, so now our vertex. Remember, our vertex comes from this point here. It's really the new origin. So left 2, up 3. So -2, 3. Our axis of symmetry is x equals -2, always the x value of the vertex, and you can see that here clearly. We're going to cut through the x-axis at -2. All right, that's what cuts the graph in half. Okay, our min and our max. Well, we have to look at our boundary first. So our interval, or our boundary, is 1 to 5. So you're going to remember those are x's. So 1 to 1, 2, 3, 4, 5. I know it's labeled there, but I didn't trust it. Okay, so here we go. 1 to 5. So now this is a very different situation from the previous problem. On the previous problem, look at what happened. Our vertex lied within the boundary, right? So that vertex was that min or that low, low, low point. But whenever our vertex doesn't lie within the boundary, like on this problem here, then this is it looks just like a linear graph, right? So then our min and max are just going to come from the boundaries, just like they did when we did our linear graph. So our vertex isn't in here, and so that's not going to be part of the answer here. So our min and max are literally going to come from the boundary. So our min is this low point here, so f of 5, it must be because it lies on the boundary. So f of 5 equals -4. And then our max is going to be f of, and that's 1 equals, and that's 0. So our min and max came from the boundary because the vertex didn't lie within. And that's something you need to make sure you understand before we get to the back. Just wait and see. Okay, so the domain and range and interval notation. So you guessed it, the domain spans all the way left, all the way right forever. So -infinity to +infinity. And our range on this one, be careful because it goes down to negative infinity. Remember, we read the range low to high, bottom to top. So how low does it go? Negative infinity, all the way up to 3 is the highest y value we use, and it is included, so bracket. Okay, x-intercepts are negative 5, 0, and 1, 0. And then y-intercept is 0, 1. Okay, so those are the attributes graphically, and we're going to refer back to this here in a minute when we do our attributes algebraically. You know, my favorite part. Okay, so find each requested attribute algebraically. You might want to sketch a graph to check your work. We probably won't have time in this video because I don't want to make it go on forever, but just be aware you can always sketch a graph to check, not to actually find the attributes, but to check, okay? If it says to use algebra, then you must use algebra. Okay, so the vertex and axis of symmetry are the easy parts, right? So for the vertex, just look at how did the origin shift. So left 2, up 7. So left 2, up 7. Our axis of symmetry is going to be that x equals negative 2, right? All right, so now let's talk x-intercept. So I'll refresh your memory like the linear notes that we did, that your x-intercepts, right? Your x-intercepts are where y is 0. So of course, right, your y values are all 0 on your x-intercepts. Okay, so x-intercept algebraically is when you plug in 0 where you see y. So we're going to plug in 0 where we see y in the equation. And again, it makes sense, I'll reiterate, it makes sense that the only variable we see is x when we want to find the x-intercept. So now we're going to solve this absolute value equation. Okay, so I'm going to jump that 7, and frankly you could, I know, believe it or not, you could jump this whole absolute, the negative absolute value, and then make it positive absolute value of x plus 2, but I already started to jump the 7, so I'm just going to do it. So negative 7 equals negative absolute value x plus 2, and then of course, since I didn't jump the absolute value, I'm going to have to divide by negative 1 to get rid of those out there. So then this is going to become positive 7 equals absolute value x plus 2. And then of course, to free the x plus 2 of the bars, remember this is where you split it up into those two equations. So x plus 2 equals negative 7, or x plus 2 equals positive 7. So we freed the x plus 2 of the bars and made two equations. And then of course we solved each. So the plus 2 needs to jump on both equations here. So this is going to be x equals negative 7 minus 2, or in other words, x equals negative 9. Okay, and then on this one, x equals 7 minus 2. In other words, x equals 5. So of course you don't want to leave your final answer like that. You want to be proper mathematicians. So negative 9, 0 is one of the x-intercepts, and 5, 0 is the other. So of course we're going to write them as ordered pairs. All right, so now y-intercept. Remember that your y-intercepts, right, when you're looking graphically, your y-intercepts is where x is 0. So that's where we plug in 0 where we see x. And again, it makes sense. That's an equals, and it didn't really look like it, did it? Y equals negative. Where I see x, I plug in 0. So like I was saying, it makes sense that the only variable I see here is y. Now, unlike this problem, the x was not isolated. We had to isolate x. In this problem, the y is already isolated, so there's nothing that needs to move sides or shift or anything like that. You just need to simply find out what this value is. So that's what we're going to do. Y equals negative. What is 0 plus 2? It's 2. And then here's where this can get tricky if you're not really thinking about it. The negative drags down, and then you just simply take the absolute value of 2. The absolute value of 2 is 2. Okay, so you really have negative 2 plus 7, because that negative dragged down, the absolute value of 2 is 2. So y equals negative 2 plus 7, which is 5. So of course, we're going to be proper mathematicians and write that answer as an ordered pair. Okay, let's get to the fun part. Max and min. So, or min and max. So remember that these are x's. All right, that's so important. Those are x's. So just like we did whenever we did the linear portion of these notes, we're going to plug in these values for x into our equation. So, oh no, on mine you can't see it, so you're just gonna have to look at your own paper. So I'm plugging in -3 where I see x into the given equation. Okay, so f of -3 equals, and then plugged in -3 where I saw x, and then I'm going to compute this value. So I'll have negative, this is going to be -1 plus 7. Again, here's where you have to be careful. So this negative drags down, and the absolute value of -1 is +1. Okay, so those two negatives don't cancel. I told you a long time ago you can't just distribute that in. So you drag down the negative, and then the absolute value of -1 is 1. So this actually becomes -1 plus 7, which is 6. So f of -3 equals 6. And then you need to find out what f of 1 is. And we're going to talk about why and how all this works here in a minute. So plug in 1, so you've got negative. Plug in 1 for x, 1 plus 2 plus 7. And then negative, this is 3 plus 7. And then drag down the negative. The absolute value of 3 is 3. Okay. And so this is -3 plus 7, which is 4. So f of 1 equals 4. So here's what I want to remind you. So first we're going to say the vertex. We don't know. The vertex is, well, we do know this part. The vertex is, hopefully you know, the vertex is the ordered pair, -2, 7. So we're going to write that using function notation. F of -2 equals 7. So the vertex, which is f of -2 equals 7, it's that ordered pair. Is it or isn't it in the boundary? Here's why you need to know. Because remember, when we did these two problems, in this case, the vertex was in the boundary, and it was the low point. I'm telling you right now, if the vertex lies in the boundary, it's either going to be the min or the max, depending upon if this graph opens down, or excuse me, opens up like this one, or opens down. If the vertex is in the boundary, it's going to be either the min or the max. And then you're only going to use one of the boundaries for either the other one, for the min or the max, depending upon what the vertex was. If the vertex doesn't lie in the boundary, then it's easy peasy lemon squeezy. You just take the boundaries, and the higher one is your max and the lower one is your min. Okay, so we need to know, is this vertex in the boundary? So you need to come over here, you need to examine the x value, examine that x value, and you need to ask yourself a very important question. You need to ask yourself, does that x value of -2 lie between -3 and 1? Okay, those x values, the boundary. Does -2 lie between -3 and 1? What's the answer to that question? Yes, it does. So that means that the vertex is in the boundary. The vertex is in the boundary. So if the vertex is in the boundary, then we need to consider it when we're finding the min and the max. So look at our y values. Remember, we're talking height. Min and max is talking height, so that's y. So then which of these is the min? Oh, that one. F of 1 equals 4 is your min. Which one of these is your max? Oh, the vertex. So the vertex lies in the boundary. That means it's going to be the highest point within the boundary. Okay, so the vertex is your max. This is your min. Remember, like I said, one of your boundaries isn't going to be used, just like it wasn't used on this problem here. One of your boundaries wasn't used on that problem. Okay, so just because I know you're probably going to want another example, let's do another example of that, okay? So on this problem here, what's our vertex? Okay, well, this graph shifted left or right, none, and down 4. So it's going to be 0, -4, right? We didn't have a left or right shift, so it's 0, -4. Our axis of symmetry is x equals 0. For our x-intercept, we plug in 0 for y, so 0 equals 2. Okay, and it makes sense. The only variable we see is x. So then I'm going to jump that -4 over. Okay, so this becomes 4 equals 2 times the absolute value of x. Then I'm going to divide both sides by 2. Okay, so I get 2 equals the absolute value of x. So then to break the x free, I've got to set up the two equations, one positive and one negative. I should have pointed here and said one positive, one negative. So now I've got my x-intercepts, negative 2, 0, and positive 2, 0. You can tell I'm trying to go fast. I don't want this video to be forever long. Okay, and then my y-intercept, I'm going to plug in 0 where I see x. Okay, and y is already isolated, so I just need to compute this. So 2 times 0, because the absolute value of 0 is 0. 2 times 0 minus 4, so 0 minus 4. So negative 4. Okay, so 0 comma negative 4 is my y-intercept on this guy. And again, remember, you can graph this. I would love for you to graph this and check all this stuff. Okay, even the min and the max. So again, I will kindly remind you that these are x's. Okay, and what we're going to do first, is we're going to find f of 1. So 2 where I see x 1 minus 4. Remember, we're also going to find f of 4. So 2, 4 where I see x minus 4. Oh my gosh, you can't see what I'm writing. I'm so terribly sorry. Okay, so here we go. I've plugged in 1 and I've plugged in 4 for x into the original equation. So f of 1 equals 2 times the absolute value of 1 is 1 minus 4. So f of 1 equals 2 minus 4. So f of 1 equals negative 2. And here f of 4 equals 2 times 4, because the absolute value of 4 is 4. Okay, and then f of 4 equals 8 minus 4. So f of 4 equals 4. Okay, so here's the important part. The vertex. Let me make sure you can see me. The vertex is what? The vertex is f of 0 equals negative 4. So the vertex is f of 0 equals negative 4. All right? So then remember, you're going to examine the x value of the vertex, because these guys over here are x's, right? So you're going to examine the x value, and you're going to ask yourself this important question. Does 0 lie between, where am I going to put it? 1 and 4. Does 0 lie between 1 and 4? No, 0 comes before 1. Okay, so no. 0 does not lie between our border here. So therefore, our vertex, in this case, is not in the boundary. So therefore, I'm trying to do two things at once, and sometimes I can't. Okay, since this is not in the boundary, our vertex is not in the boundary, I'm not going to do like what I did here and highlight that value, because I don't care about it. It's like this situation. It's like this situation where the vertex was outside of the boundary. I don't care about that value, because it's not like this situation where the vertex was in the boundary, like on number 3 here. Okay, so I don't care about that value. I'm not going to highlight it. My min and max come from only my boundary. So of course that f of 1 equals negative 2 is my min, and f of 4 equals 4 is going to be my max. So I couldn't really box these, but hopefully you catch the drift. Those are your final answers. Okay.